Hello. In this video, we're going to talk about changing the amplitude and the period for our reciprocal trig functions. So as a quick reminder, for all of the reciprocal trig functions, cosecant, secant, and cotangent, our amplitudes are undefined. For cosecant and secant, the period would be 2 pi divided by b. And for cotangent, it would be pi divided by b. Okay, let's take a look at some examples. I want to try one of each kind. First of all, here again, our amplitude, it's cosecant. For all of these, our amplitude, let's do that. Amplitude is undefined. And our period, this is a cosecant graph, so it's 2 pi divided by b. Our b in this case is 4/3. Okay, so that means I need to take 2 pi divided by 4/3, or 2 pi times the reciprocal 3/4, which would give us 6 pi over 4. And if we reduce that, we would have 3 pi over 2. Okay, so that's our period. Now, the nice thing with cosecant, if you recall, the asymptotes start at 0. So that one obviously is not going to change. Let's see if I can get it on here. 0. And then the period is 3 pi over 2. So now I should actually have another asymptote at this line right here, 3 pi over 2. So that makes it a little bit easier to get started. Whoops. Oh, struggle. Okay, now I need to have cosecant go like this and like this in that period. So in between there, to cut that in half, I have to have my first upper sort of like parabola looking shape. So I'm going to have to cut this now in half. That would give me 3 pi over 4, or you could just count and cut those squares in half. You get 6 squares, so at the third one I would be here. Okay, so now that represents really one period, and I need to just fill in what I've got to represent that. So, okay, so the amplitude is undefined, but this right here still impacts where we start at. With cosecant, we usually start at 1. We're going to start at 2 now. So halfway in between these right here, I'm going to have my first dot. So I'm going to put, oops. So that'll be at 2. Let's see if I can make it right. There we go. Okay, and then same thing with this one over here. It's going to be at -2 halfway in between, like that. And then I can just draw my cosecant graph to start. Looks like that. And so now we just need to repeat that throughout the rest of this graph. So I'm going to start by sketching in my asymptote lines. Okay. All right, and this goes, remember to do all the way out to the edge of each graph that you do. Okay, and then do the best we can with this here. Okay. Ooh. All right, so there's 2 cosecant 4/3 theta. All right, let's try taking a look at our next one. This one I find to be a little bit more challenging is the secant graphs. And you'll see why here in a second. But, okay, our amplitude, once again, undefined. And the period, in this particular case, would be secant is 2 pi divided by b. Our b here is 2. So we get pi. All right, well, that's not too bad. Now, so once again, secant does this thing, but the y-axis splits this in half. So I should have the y-axis kind of go through that first one. So coming up with your period is a little bit tricky. Our period is pi, but I mean, I guess figuring out where the asymptotes go based on your period is the tricky part. So, all right, I have a period of pi, and I need to get those two things. But remember that y-axis splits that in half. So I need really a half a pi and then a half a pi. But because a half a pi is split in half by the y-axis, half of 1/2 is a fourth. So I really have, that would represent my first, that would be right here, okay? And then if I do this, that would give me the second one right there. So now I just want to write in my asymptote lines, and notice I've got a half, 4 squares, there is 1 pi. So that represents my period. Okay, so now I just need to fill in an asymptote line every 2. Every 2 squares, I should say. Okay. Ooh, a lot out of control there, but all right. So now, okay, so our amplitude is undefined, but again, looking at that A value is 3, so that's really where we're going to start. And you know I'm going to have a dot at 3, okay? And my first is going to go up like that. So, and then at -3. And those two represent, should be my period right there. And again, that is pi, so we're okay. So now I just have to fill out a bunch of these all the way through on either side. Okay. As my dog is walking through here. Okay. All right, so that would give us our 3 times secant of 2 theta graph. All right, lastly, let's take a look at a cotangent graph. I think these are actually the easiest ones to graph, and hopefully that will make sense here in a second as well. Amplitude for this, once again, undefined. The period here would be pi divided by 1/2. So that's going to give us 2 pi. All right. So here's why this makes this a little bit easier, because cotangent, just like cosecant, has an asymptote line right here at 0. Okay. Now the nice thing about cotangent is there's no 2 graphs like these two, right? It's just one. Okay. So when we see a period of 2 pi, I know I can put another asymptote line. Ooh. Right there. And that's going to be represented, and that's going to actually be just one of my cotangent graphs. And so let's put that in there. I know halfway in between this, cotangent is at 0. So halfway between 0 and 2 pi would be pi. And then halfway in between that 0 and that dot, I should be at 1, usually for cotangent, but this has been multiplied by 4, so I'm going to be up here at 4 at pi over 2 radians. And then by the same token over here at 3 pi over 2 radians, I'd be at -4. And that would be one graph right there. And now I just repeat that on the other side. So Okay. And then I'm going to draw my line here. My graph. And draw my graph over here. I still need to sketch in one more asymptote line here. All right, we've got it. And that would be our y equals 4 times cotangent 1/2 theta. And that's an example of each of the different types changing their amplitude and period. All right, we'll see you later.